And in this final video on index laws, I'll be talking about fractional indices. And this is one to show your mum or dad if you want to freak them out about the maths you're doing. This will scare them a little bit. Okay, so fractional indices. This looks horrible, and kind of is. I'm not going to shy away from that. So firstly, we want to figure out what is going on. If you have something raised to a fraction or power, what does that mean? And so firstly, I just want to look at this and have a look at what this means. So square root of 4 times the square root of 4. What is that equal to? So the square root of 4 is 2. 2 times 2 is equal to 4. Okay? And so we learned previously that if you've got a to the power m times a to the power n, this is equal to a to the power m plus n. Alright? So what we've got here is, this is 4 to the power something. Okay? 4 to the power something times 4 to the power of something, that same something, is equal to 4 to the power 1. Alright? Now instead of something, let's not call that something, let's call it x. Okay, we want to know what this power is. What does this square root, what power will that be equal to? Now you remember, if you're timesing them together, you add the indices. So what we're going to do is add the indices together here. In other words, 4, if you add those powers together, you get x plus x is equal to 4 to the power 1. In other words, 4 to the 2x is equal to 4 to the power 1. What this means is that 2x is equal to 1. And dividing by 2, you get x is equal to a half. In other words, square root of 4 means 4 to the power of a half. That's what a fractional power means. If you raise something to the power of half, that means it's the square root. And you could also show that the cube root of something, cube root of 27, that can be shown that it means 27 to the 1/3. The quartic root of a number is equal to 64. Sorry, I said quartic but wrote 3. Quartic is 4. That's the power 1/4. And it can be shown, and I'll write it on the next page, that the index law, if a quartic root or a cubic root or a square root, that could be written like that if you really wanted to, that means the fractional power. So 1 over that power, 1 over that power, 1 over that power. Okay? So on the next page, I'll write that down. Our 8th index law says that a to the power 1 over n means the nth root of a. And that's it. So let me go into some examples of this. So an example, let's do 16 to the power of a half. Okay, 16 to the power of half. What that means is the square root of 16. Now we don't bother writing this 2. We just write the square root of 16. It's just like that. That is equal to 4. Could not be easier, eh? Beautiful. So that's it. Let's do 16 to the power of a quarter. What's that equal to? So what that means is the quartic root of 16. What that means is it's asking us what number, if you times by itself 4 times, will get 16. Well, that answer is actually 2. The reason for that is 2 times 2 times 2 times 2 is equal to 16. And so we get the quartic root of 16. Very good. I might just do, let me just do one more just so that you get the idea. 64 to the power 1/3. Let's do that. That 3 indicates the cube root of 64. What that's asking us, what number did you multiply it by itself 3 times to get 64? And that is 4. Because 4 times 4 times 4 is equal to 64. Beautiful. So that's that index law number 8. Up to 8, 6, 7, 8. Yeah, probably. I'll do one more index law. But that's the basics of that, and I'll do the next index law first, and then I'll do some more difficult examples. But index law number 9 says that any number a to the m over n, what that is equal to, remember the n gives us some roots. I'll just write it like this, right? So a to the power 1 over n times m. They're the same things. And so that could be written as a to the power 1 over n to the power m. Okay, because we're timesing. Remember this index law here, where if you've got everything raised to a power and then to another power, you times them together. That's our first thing. So that's the first one. You could also write it as a to the m times 1 over n, in other words in the opposite order. So that's equal to a to the power m to the 1 over n. What this is the nth root of a raised to the power m, and what this is a to the m, the nth root of that. Okay, so these two things are exactly the same. So this is saying that that is equal to this or this, whichever one works out to be the easiest to use. You can use either of these. Okay, in other words, you can take the nth root first and then raise it to the power of m, or you can raise it to the power of m and then take the nth root. It doesn't matter which order you do, both are true. Okay, so let's do some examples of that. Let's do 36 to the power 3 over 2. Now these are a bit of fun. They look horrible, but they're fun. Okay, so I'll do it both ways to show you what I mean by the fact that you could use either of these. These are the ninth law. So this could be 36 to the power 3. So doing the 3 bit first, and then doing the square root. So I'll write the 2 just to show you. So that's using this one here. That's using that one. I've cubed it first, and then I've done the square root there. Okay. Now 36 cubed is a big number. Let me just. I've got to prove to you that this is all the same. So I'm not going to cheat you. So I'll just go to calculator. 36 cubed. 36 times 36 times 36. So we get 46656. 46656, and what we want to do is the square root of that. Okay, so back to your calculator. Now I'm going to take the square root of that. Can I easily do that? Square root, and we get 216 equals 216 when we take the square root of that. Okay, so that would be one way to solve this. Let's do that question again. Now let's do the other way. Let's do it this way first. In other words, I'm going to take the square root first and then raise to the power of m. So I can write this as the square root of 36, so that's the bottom 2 there, and we're going to raise that all to the power of 3. So you can see how these two are different, but you're just doing the powers in a different order. Square root of 36 is 6 to the power of 3, which is equal to 216. So both ways are correct. You get to decide whenever you're doing a question which way is easier. Usually with these powers it's better to take the square root first because it keeps the number small, rather than it getting massive like this. Cool, let's do a couple more examples. See, these are fun. I bet you're sitting at home going, oh gee, I can't wait to get going with these. These are fun. Let me do, I'll go into some algebra. Let's do some algebra, okay? I'll do some numbers first, but I'll show you what I mean. 2 to the power 1 over 8 times 2 to the power 3 over 8. Let's have a look. It looks horrible, but just continue to follow your index laws. What happens when you've got the same base multiplied together? You add the powers together. So that's 2 to the 1/8 plus 3/8, which is 2. What's 1/8 plus 3? Well, it's got the same base, so all you need to do is add the top. So that's 4/8, which is 2 to the power half. What is 2 to the power half? That's the square root of 2, and that's your answer there. That's the nicest answer. Don't go to 1.414 putting it in your calculator. This is the nice answer. Accurate, exact. Okay, another example. Let's go into algebra now. I think I'm just looking at some examples and that sort of thing. Again, x to the power 3/4 times x to the power 2/5. Again, add the powers together. So that's x to the 3/4 plus 2/5. Yeah, it gets a bit messy up here. Now, to add fractions together, they need to have the same denominator, the same bottom line. So what do they have to have? Let's put 20 on the bottom line. So 20 plus 20. We've multiplied that 4 by 5. 3 by 5 is 15. We've multiplied that 5 by 4. 2 by 4 is 8. So that's equal to x to the power 15 plus 8, 23 over 20. And that's the perfect answer. Don't need to touch it. Don't need to. Please don't put that into mixed fractions or anything like that. This is beautiful. Don't touch it. Good. There's your answer. Last example. Again, these look horrific, but you know, just deal with them one step at a time. Follow your instincts. Don't let it intimidate you at all. Looks horrible. If you're good with your fractions, then you'll be fine. 3 and 3/8. Let's do this. Firstly, I hate the divide sign. Let's write this as a fraction. So that's all I'm going to do is just write it as a fraction. 3/8 and 4/7 over 3 and 3/8. Okay, beautiful. So m's, nothing's going to affect our m's. They will just stay. And so what we'll do is we'll rewrite that. m 3/8 will stay on the top line. That 3, it's the only number present, so that'll stay on the bottom line. All we have to do is deal with these n's. So what will happen is we'll have n, we'll leave that on the top line, and it'll be 4/7 minus 3/8. 4/7 minus 3/8. That's just using index law number 2. Good. Let's just fix this up. And now this is horrible. m 3/8. 7 and 8. What's the lowest common multiple of those? Is there anything lower than 56? No. Why did I get into this? 56 minus 56. I've sort of jammed up here. 7, we multiply that by 8 to get to 56. And so 4 times 8 is 32. Here 8, we've multiplied that by 7, so that'll be 21. So this is equal to m 3/8 n 32 minus 21 is 11/56. Oops. 56. I accidentally pressed the button on the pen. Over 3. And that's your answer. It looks horrible, and it is horrible. But there you go. There's no simpler answer than that. That's fractional powers. Get used to them. They're a lot of fun. I say, giggling under my breath. Thank you.